Please don't walk away. Because I can imagine that there are questions from the audience. And I have a question. What does IAEA or organizations like the WHO, what do they think about your studies? Did they give a statement or?
Why don't you ask them? I don't think they don't care because this is...
I don't know the telephone number.
You have the phone directory. No, seriously. I don't think they are very interested in other organisms than human beings. So because of this, I don't think they care a damn about it. But it's not quite true because recently there's been some interest in the impact on how these professionals perceive the impact of radiation, not only on humans but also on other organisms. So perhaps they care a little bit, but I'm not sure. You should ask them.
Okay. Please allow me another question. So we soon have fixed that problem. Please allow me another question. And in this wonderful, stylish, I think it was really a nice movie, this Austrian movie, very nice pictures, and he also shows some problems. And what I think it really shows very good is how these scientists, they protect themselves from radiation with the masks or with these suits. And aren't you worried when you're working on that places that you could be contaminated?
I think you should compare this to the situation in the März film, because they did everything you should never do. They were out there sitting on their pants on the ground. It's a no-no. They were using their naked hands. They touched the vegetation. They had their tripod for their camera that was not provided with plastic bags. So these people, they are probably bringing home plutonium to Italy somewhere and putting it in their office or some other place where perhaps one small baby is crawling around and saying goo goo and putting their hands in the mouth. So there are many bad things in this März movie in that respect. We of course are careful. I say that to my wife all the time. Don't worry. It's not really a problem with the background radiation. It's what you eat. So you should be careful about your choice of food and what you do with the food and the drink, of course.
But is it difficult to get a permission getting into the exclusion zone of Chernobyl? What does it need?
No, it's very, very easy. In fact, the people responsible for the Chernobyl exclusion zone, they have started a tourist office. So you can go to their website and you can sign on for a tourist trip of 1, 2, or 3 days. You will be transported around in this area, and you can see lots of different kinds of things. But not very much, because many of these tourists, they complained they saw so few mammals, because these films, they gave the impression that there were so many big mammals around. So the tourist operators, they have made a small zoo in Chernobyl village, where they can show one wild boar and a couple of deer and a wolf, so the tourists get something for their money. It's also interesting to look at the people who join these tourist trips. I think the average age is something like 20, 25. 95% are men, of course. I didn't see any people on honeymoon on one of these trips. It doesn't appeal to women somehow.
Okay. Hat jemand eine Frage? Na, ganz viele. Also jetzt kommt doch hier.
Okay, thank you. Thank you for this very interesting presentation. I was wondering, what is your expectation for the next 50 or 100 years? Will the nature and the animals get used to the radiation, and then there will be many more, or will it be much less because they are all ill?
It's a very good question. I think Andreas Erhard, he should answer this partly, because he was collecting lots of information about the population size of different plant species. But I don't know. We have one paper that will come out in 1 week's time on resistance to radiation in a species of bacterium from the Chernobyl exclusion zone. It's a species of bacterium that's living on the feathers of barn swallows. And this bacterium is a Bacillus licheniformis. And what we can show is that bacteria of this particular species from intermediately contaminated areas are more resistant than bacteria from swallows in uncontaminated areas or highly contaminated areas. And this is a really strange result, but I think it's possible to explain it. But anyway, this is the only study suggesting that there is some adaptation to radiation levels. I think for most organisms you will perhaps see more of these bad effects, the tumors and increased level of mortality, reduced sperm quality and stuff like that. But it's difficult to say because you also have to remember that there are different species with different longevities. Humans have an average generation time of 30 years, and therefore we are still in the first generation after Chernobyl. Whereas the swallows are in generation number 25, and the small mice, they are in generation 35, and these microorganisms, they are in generation, I don't know, 10,000 or 100,000 or something. So, of course, if you have more generations, you have more possibilities for things to change. But it also is important in the sense that if we are talking about effects of radiation on humans, we can't really expect to see accumulation of these effects across generations because we are still in the first generation. Yes.
Well, thank you very much for giving me the word, but actually you said practically all I was going to say. That I think the longevity, the generation time is a very important point. So trees, for instance, within plants, will have a much longer generation. Ich kann ja Ihnen ja auch Deutsch sagen.
Ach so.
Also, Bäume haben natürlich viel längere Generationszeiten als einjährige Pflanzen, und ich würde bei einjährigen Pflanzen, kurzlebigen Pflanzen, viel eher einen adaptiven Effekt erwarten, dass die vielleicht schlechte Mutationen loswerden können durch die kurze Generationszeit, als das bei langlebigen Organismen der Fall ist. Also der Effekt auf die Klimaxvegetation, das, was wirklich die Vegetation bildet, der ist sicher viel drastischer als der Effekt auf die, sagen wir, Wildkräuter oder Unkräuter, kurzlebige Pflanzen, und das dürfte natürlich für die Tiere genauso sein. Insekten, die haben eine tendenziell größere Chance, vielleicht da mit der Zeit diese ungünstigen Mutationen loszuwerden, weil einfach die gesundesten Individuen überleben, als das bei den Säugern der Fall ist. Deshalb hätte es mich wahnsinnig wundergenommen in diesem österreichischen Film, wie der Gesundheitszustand dieser Wölfe effektiv ist. Darüber haben die überhaupt nichts gesagt. Das hätte mich sehr gewundert. Vielleicht haben Sie die Daten auch noch nicht. Also das kleine Ergänzung. Dankeschön.
Sehr gut, du kannst aber alle Fragen beantworten.
Ja, Eine Dame.
I wondered, you mentioned the birds that left one zone to another one, and we heard them singing. How do the birds know? Why do they move?
I don't think they know.
Yeah.
But what is the case is that some individuals are living in areas with lots of food. Other individuals are living in areas where there's less food.
Yeah.
So, as I've shown, there is an effect or relationship between abundance of birds and radiation level. There's also a similar relationship for butterflies, for bumblebees, for spiders, and so on and so forth. So in more contaminated areas, there's less food, and perhaps that affects their behavior. But also, of course, the alternative interpretation is that there are more mutations, and because there are more mutations, you will have these effects on the quality of the song they're producing.
So that means that the food for the birds was a small organism, and they all died, do not exist anymore.
No, I wouldn't say that, but there is a smaller abundance of these.
Small abundance?
Yes, there's a reduced abundance. Es gibt weniger.
Thank you very much for your laborious work. And I looked at the tree growth experiments, and there are, every certain years, there is increased growth, more than average. And is this data related to other indicators or climate-related issues? And then another thing was that you were talking about the Bacillus mecaniformis, and if you work in a microbiology laboratory, then it is more like a selection rather than gaining resistance. So if we consider a human population, so that not the resistant, the ordinary people get out selected, and then certain mutated people happen to survive. And then I think that's the lesson we could learn from bacteria, we think.
Yes. First the story about the trees, because the most obvious thing is that since these trees in Chernobyl, they are growing in very sandy soil, perhaps it's very dry years that make the trees grow poorly. But I try to enter weather conditions the previous year as predictors in the statistical models, but it didn't explain very much of this variation. So there were no obvious effects like that. But we can show for pine trees in the forests in Fukushima similar kinds of effects. And Fukushima is a very wet and humid place. So this is also consistent with my interpretation. There's probably not these obvious climatic factors. As concerns the bacteria, the levels of radiation that we used in our experiments to assess abilities to sustain radiation, we used extremely high levels that are much higher than the levels anywhere in the surroundings of Chernobyl. And still, it was the case that these bacteria that came from swallows and swallow nests in the areas that had an intermediate level of radiation, they were better able to sustain this extremely high level of radiation in the lab experiments. And of course, there must have been some selection going on, but I still think it's more likely that you have some adaptation given the nature of the response to this incredibly high level of radiation. Otherwise, it should be more or less the same because it's so high that everything should be sapped. But these intermediate ones, they perhaps didn't like the extremely high level of radiation, but they didn't mind so much if they have a mind.
Eine letzte Frage nehmen wir noch rein. Eine letzte Frage.
I also like to thank you very much for your valuable work. I was wondering, you were showing dose rates and the kind of instruments you used, and I think it was also it was mostly gamma radiation that you measured. Did you also assess beta radiation, strontium, or even alpha? Because this is so difficult to do. I wonder, because you talked a lot about plutonium, americium, and so on.
Yes.
Yeah.
I didn't talk a lot about plutonium and americium, but I talked a little bit about that. And the reason why I did it is that these are so toxic and have so bad effects on any organism. So, surprisingly, there's hardly any work done in the field on these radionuclides. Our main limit in our work is the carrying capacity of our rental car. And if the rental car company knew what we were doing with their cars, they would never give us a car again. So they hate people taking their cars to contaminated areas. And especially if you bring in contaminated material into the car, it's a no-no. So what we have done is, we can, in our small car, transport 500-600 kilograms of lead, and that's about the limit. And another excuse, another excuse is that we have had very little funding. So typically, our funding for this research, even though we have published perhaps 75 scientific publications during the last 25 years, our average funding in a year is something like 10,000 euro, including everything. Salaries for our helpers in Ukraine and so on. And I don't know why, but it's just extremely difficult to get funding for this kind of work, because most people who are assessing grant applications or assessing our manuscripts for that matter, they typically write, "This is not of general interest." And then, of course, I say when I have the possibility to express myself, well, perhaps it's not of general interest. It could even be of specific interest, but still interesting. But that's where my U.S. colleague Tim Mousseau comes in, because he used to be a dean at the University of South Carolina. And what he did on a typical working day would go and knock on the door of the nearest 10 or 20 billionaires and ask for, please give me $1 million or $5 million. Sometimes they said, yeah, it's a nice day, we'll give you 5. And this is also how we get funding for our research. He's very good at this. And apparently also in Japan it works the same way. I remember last year Tim was giving a number of popular seminars in different places in Japan, and there was this little old lady, 75 years old, with a small envelope tucked under her arm, and she came up to Tim, and then she handed over this envelope with $25,000 inside. She didn't say anything. She just walked away. So any people with envelopes is over here.
Is there the other side too, that there are interests to stop you in your work?
No. We never had anybody objecting to anything we have done. People are very helpful, also officials of all different kinds in Japan, in Ukraine. I think the most negative response we ever had was when I was put into Russian jail for 3 days for crossing the border between Ukraine and Russia without having my passport stamped.
But just to follow up on that, do you think that the gamma radiation is a good indicator for the other types too?
I don't know. I really don't know. But even if there were effects of the other kinds of radiation, I'm sure perhaps there is, but would we expect it to be acting in the same direction at the same intensity or not? Well, I don't know. I think the only thing I can say is that we are awaiting another little old lady with a larger envelope.
I really hope it's coming soon, this envelope. Ich würde gerne schließen hier diese Veranstaltung. I declare this closed. And I can do nothing than really thank you for coming here and thank you for your absolutely important work.
Ja, Beatrice hat natürlich ganz vergessen, es geht ja noch weiter in den anderen Städten, ich glaube am Montag, und dann vor allem, das kann sie nicht selber machen. Ganz herzlichen Dank der Beatrice für die grosse Kiste, die sie da beigestellt hat, zum 5. Mal, und ja, einfach